Imagine an AI that doesn't just read about the world. It actually understands it by moving through it, touching it, experiencing it like you do. That's embodied AI, and it's about to completely change how machines learn. Hey, I'm Mark, and today we're breaking down Google DeepMind's world models and why this might be one of the most important shifts in artificial intelligence you've never heard of. So here's the thing. Most AI systems you know about, ChatGPT, image generators, recommendation algorithms, they're trained on data. Tons and tons of data fed into a computer that finds patterns. But there's a massive blind spot in that approach. If I describe a coffee cup to you, you might understand what it is. But if I've never actually held a cup, never felt the weight of it, never experienced what happens when you tilt it too far and coffee spills everywhere, do you really understand it the same way? Exactly. That's the gap embodied AI is trying to close. Embodied AI is the idea that true intelligence requires interaction with the physical world. It's not enough to process information. You need to actually do things, see the results, fail, adjust, and learn from experience. Think about how you learned to ride a bike. No amount of reading about balance and pedaling would have taught you the way actually sitting on a bike and wobbling around did. Your body, your senses, your movement through space. That's where real learning happens. Embodied AI tries to replicate that. Now, Google DeepMind has been working on something called world models, and this is where it gets really interesting. A world model is basically an AI's internal simulation of how the world works. It's like if you close your eyes right now and imagine moving your hand through the air, you can predict what's going to happen because you have an internal model of physics, gravity, and how your body moves. World models let AI systems do something similar. Here's how it works in practice. Imagine you give a robot a task. Let's say you wanted to move a block from one side of a table to the other. Instead of being explicitly programmed with every single movement, or instead of just memorizing thousands of examples, the robot develops a world model. It learns that blocks are solid. They don't pass through tables. They move when pushed, and gravity pulls them downward. Once it has that understanding, it can figure out new ways to accomplish the task without being retrained from scratch. It's generalizing from experience. The breakthrough with DeepMind's world models is scale and efficiency. They've shown that you can train an AI system by letting it interact with simulated environments, not real robots, but digital ones. The AI moves around, manipulates objects, watches what happens, and builds up this internal understanding of cause and effect. Then, crucially, that understanding transfers. You can take what the AI learned in simulation and apply it to real-world tasks with physical robots. That's huge because simulation is cheap and fast, but the real world is expensive and slow. But here's where embodied AI gets even more profound. It's not just about robots. The principles apply to any AI that needs to understand the world. Think about an autonomous vehicle. A self-driving car isn't just processing images and following rules. It's building a model of how pedestrians move, how other cars behave, how wet roads affect traction. It's embodied in the sense that it's constantly interacting with a dynamic environment and learning from those interactions. Or think about language. When we talk about a chair, we're not just repeating sounds we've heard. We understand what a chair is because we've sat in one, felt it support our weight, moved it around, maybe bumped our shins on it. An embodied AI approach to language would involve connecting words to actual sensory experiences and physical interactions. That's why some researchers think embodied AI might be the missing piece for AI to truly understand language the way humans do. Now, you might be thinking, okay, this sounds amazing, but what's the catch? Well, embodied AI is computationally expensive. You're not just processing static data. You're simulating physics, managing interactions, storing, and updating world models. It requires a lot of resources. And there's still the question of how much embodiment is actually necessary. Do you need to simulate every detail of the physical world, or can you get away with approximations? Researchers are still figuring that out. There's also a philosophical question lurking here. Does an AI actually need to experience the world, or does it just need to model it well enough to behave intelligently? Some people argue that embodied AI is the true path to artificial general intelligence, AI that's as flexible and adaptive as humans. Others think we might be able to skip the embodiment part and achieve intelligence through pure computation. Honestly, we don't know yet, and that's what makes this field so exciting. What's clear is that embodied AI is already showing real results. DeepMind's robots trained with world models are solving manipulation tasks that were previously impossible for AI. We're seeing sim-to-real transfer work in ways that seemed like science fiction a few years ago. And the more we understand how embodiment drives learning, the better we can design AI systems that are more capable, more efficient, and more adaptable. The deeper insight here is that intelligence isn't just about information processing. It's about interaction. It's about having a body, or a simulation of one, that lets you test hypotheses about how the world works. It's about failing, learning, and building better models. That's true whether you're a human learning to walk, a robot learning to grasp, or an AI learning to navigate a complex environment. So the next time you hear about embodied AI or world models, remember that it's fundamentally about this idea. Understanding comes from doing. Not just reading, not just observing, but actually acting and experiencing consequences. That's what makes embodied AI different. And that's why it might be the future of how we build truly intelligent machines. If you want to stay on top of breakthroughs like this, the ones that are quietly reshaping AI, hit that subscribe button. We break down the tech that matters in plain English every week. Thanks for watching, and I'll see you in the next one.